Okay, so I'm going to go ahead and turn all this stuff back on. All right, you know what? Let me turn it all off. Let's leave it off. Okay, and I'm going to go to the last page of Climate Consultant. And actually, no, it wants me to go back and turn some of this stuff on, I guess. I don't know. All right, we'll go back. See, there's a thing for best design strategies. I got to find that button.
It's at the bottom.
Down here?
No, to the left is the sidebar. To the left is the last one.
Ah, there it is. Okay, so there is the best design strategies. We'll click next. Okay, all right, so the last page of Climate Consultant will give you little synopsises of different ways that your building can be made more efficient. So for example, if we click on the first one, for passive solar heating, face most of the glass area south to maximize winter sun exposure, but design overhangs to fully shade in summer. Okay, so we're going to be doing an exercise today where we figure out how much sun we can block from coming into our house at certain times of the year. Okay, so notice a couple things. One, assume that north is up and south is down, which is what the little arrow says. Do you see much in the way of doors and windows facing east or west? There's one window there. There's no doors. There's a door there facing to the east. But for the most part, it's opaque walls, right? And notice that the building has large windows that are facing to the south, and then it has the balance of the windows and doors facing to the north. Okay? Notice the differential between how big the windows are to the south and the size of the windows to the north. All right? Now, it doesn't always work that way, right? What if you are on a lot and your lot happens to face east-west? So you've got no side yards. Are you going to put all your windows facing south? That's what my house in La Quinta is like. I have a lot, and the lot is 50 feet wide and 100 feet deep. But facing to the south, I've got a 5-foot side yard with a block wall. Can I get much in the way of ability to put a lot of southern glazing in? Not really. You have restrictions. This is one of the things that makes passive design complicated. Okay? Like, you guys think about conduction, right? And conduction is easy to understand because you're only thinking about heat being applied in one place and it traveling to another. But look at a building. A building can have heat applied to the outside or it can have cold applied to the outside. At the same time that cold is applied to the outside, you can have sun blaring in through a window, heating up the inside. And then you can have people inside that heat it up. And you can have TVs inside that heat it up. And then the cycle can change, right? Now it's hotter than crap outside, and maybe you figure out a way to block out the sun from getting in, but you still have the people. So when you look at a building, they are so much more complex and have so many factors that are very different than looking at something simple like conduction through a solid material. Okay? All right. So this is one other thing to sort of take into consideration, right? Notice that, again, north is up, south is down. Which way is the length of this building oriented, this little one? So the long axis of the building is north-south, which means that the windows, predominantly the long sides of the building, are going to face east-west, right? And so you'll notice that this is not the preferred choice. Sometimes you don't have a choice, okay? And that instead, what they're recommending is that you elongate east-west so that you have long north and south sides, and that you plant a tree on either side to block the sun from getting in there. Okay? This gives you the ability to print it or close it. I'm going to close it. All right, so this was another strategy we talked about, which is a thoroughly insulated and sealed house, right? This is the idea of using internal gains. So you got TVs, plants, lights, fan motors, people, all inside, right? And if you close up the house, you can basically keep some of that heat inside of the house. High mass. And I want to point out something in high mass here. Notice that concrete floors are mass elements, right? So concrete is a thermal mass element. And it's different to have the concrete floor be the thermal mass element as compared to a wall. In order for thermal mass to be effective, it needs to not only be on the floor, but it needs to be in the walls. Okay? Now, we don't design a lot of brick and block buildings in California, right? Most of our construction is either light gauge steel stud framing or wood stud framing. So there are different things that you can do to kind of introduce thermal mass into the middle parts of the house. You can use concrete block cladding, for example, on a wall. Or you can put a chimney inside. Or you can put a big planter that's exposed to sunlight. There's a number of different things that you can do to increase thermal mass in a house without necessarily building the house out of a material that's got high mass. There's a question, so I'm going to pause this. So there were two questions asked in regards to this. One of them was, is that just a regular old concrete floor, or does it have something in it? No, it's a regular old concrete floor. It's either concrete, or it could be a tile floor over concrete, or it could be a thick mortar bed with brick over it or something. Okay? Second question was about building what I believe would be the equivalent of a dual skin building, and that is not what this is talking about. Okay? I mentioned in the discussion that what the most efficient building that you could build in our area is going to be a concrete block building with thick insulation on the outside of the concrete block. And that what I mentioned is that the concrete block is going to act as a dampener. So we talked about dampening during the notion of periodic behavior. So it's going to lower the amplitude of the curvatures, flatten it out, right? Because it'll absorb heat and then release it. And then the insulation keeps the bad temperature from outside from getting inside. Okay? But that is not necessarily the most efficient way to build for earthquake, right? So again, architecture is complex. You can build block buildings, right? A block building with exterior insulation is going to be substantially more expensive. Not substantially, it's going to be more expensive than a standard stick frame building or a steel stud building. So, all right. Part of what I'm going to have you guys do is to kind of go through these strategies and kind of get an idea of, how do they apply to this notion of designing with climate and passive design. Which I want to bring up one more issue. So in my mind, the way that I think of this is that there is passive design, 100% passive, which means that it doesn't use any additional energy. Okay? There is active design, heating, ventilation, air conditioning, which uses lots of energy. And then there are these semi-passive methods like the whole house fan, which uses a little bit of energy, but works with the passive techniques to kind of create a much more energy efficient sort of model. Okay? So I tend to lump the whole house fan in with the passive techniques, even though technically it's using some energy. Okay? So, all right. I've got a few minutes, so I'm going to look at a few more of these, and then we'll let you guys take a break and then go through some more of these. All right, so let's take a look at this one. Whole house fan, right? So the notion of the whole house fan, right, works with the idea of taking the cooler outside air, right, during summer and flushing it throughout the house and then running it out the attic and cooling off the attic. How many of you have ever gone up in your attic, if you have one? It's hot up there, isn't it? I was up in the attic yesterday or day before doing electrical out in the desert, and it's hot. It's very, very warm up there, okay? So if, in addition to flushing the house out with cool air, right, you also flush out the attic, it provides cooling in two different sorts of ways. So remember this thing called diurnal swing, right? So I can't back up to it, so I'm going to leave it alone. But the idea is that in the summertime, is 62 cool? The temperature 62 is pretty cool to a human being, right? It's not cold, it's just cool. And in the summertime, the overnight lows might be 62, 63, 59. Your daytime high could be 95. So your house gets really, really hot. But if you take a 95-degree house, right, and you take 62-degree air and you move a lot of it through the house, it takes all that heat energy out with it. So traditional passive home and temperate climates used lightweight construction with slab-on grade and operable walls and shaded outdoor spaces. So I think that was the traditional way of building in climates like ours. But I think what they've discovered since then is that heavy mass on the inside, right, somehow coupled with insulation on the outside is also a beneficial way of going. Let's take a look at a few more. There we go, right there. So exposed mass to the inside, block or brick or something, and then heavy insulation on the outside. Okay? Here's one that you guys are going to be working with quite a bit, which is heavy overhangs to block out unwanted solar gain, but the ability to allow solar gain to come in to the house when you need it. One of the problems with this is caused by the notion of thermal lag. Okay? Would you guys say that September is hot? September is pretty darn warm, right? Yeah. Would you guys say that March is pretty cool? It's been pretty cool this month, right? Did you guys realize that the sun is in the same position in March as it is in September? Approximately, because that's when the equinoxes are. And so that's one of the issues with this, right? That, June 22nd is definitely that position, right? And December 21st is definitely that position, but March and August, or March and September, are that one. And the climate profiles at that time are very, very different. So one of the things that I will advocate for is the notion of movable shading. That is, shading that in March, right, you can retract and let the house warm up, and in September you can put out and keep the sun from getting in the house. Okay? All right, that's enough. I'm going to let you guys go through some of these other things and experiment with climate consultants yourselves right now.